So in this session, we will be covering all the problems related to R, R1, R2, R3 and capital R. So take the first question. In triangle ABC, prove that R plus R1 plus R2 minus R3 is equal to 4R cos C. So first let us take R plus R1. R plus R1. So R we can write it as 4R sin A by 2 sin B by 2 sin C by 2 plus R1 we can write it as 4R sin A by 2 cos B by 2 cos C by 2. So from these two, if I take 4R sin A by 2 common, we will get sin B by 2 sin C by 2 plus cos B by 2 cos C by 2. Now this bracket is in the form cos A cos B plus sin A sin B, and the formula is cos A minus B. So here 4R sin A by 2. So we are applying that formula. So we will get cos B minus C by 2. Now the same way we will take R2 minus R3. So R2 formula is 4R sin B by 2 cos C by 2 cos A by 2 minus R3 is 4R sin C by 2 cos A by 2 cos B by 2. So we can take 4R cos A by 2 common. So we will get sin B by 2 cos C by 2 minus cos B by 2 sin C by 2. Now this bracket is in the form sin A cos B minus cos A sin B. Formula is sin A minus B. So 4R cos A by 2 sin B minus C by 2. Now after finding R plus R1 and R2 minus R3, let us add both of them. So we will get R plus R1 plus R2 minus R3 is equal to 4R. If we take common, we will get sin A by 2 cos B minus C by 2 plus cos A by 2 sin B minus C by 2. Now it is in the form sin A cos B plus cos A sin B. So it is sin A plus B formula. So 4R into sin A by 2 plus B by 2 minus C by 2. So that is 4R sin. This can be written as A plus B minus C by 2. Now you see, it is properties of triangles, right? So we know that always A plus B plus C is 180 in a triangle. So A plus B can be written as 180 minus C. So 4R sin 180 minus C by 2. So that is 4R sin 180 minus 2C by 2. If we divide this whole bracket by 2, we will get sin 90 minus C. And we know that sin 90 minus theta is cos theta. So that is 4R cos C. And this is RHS. So here we have to prove it by using trigonometry. And also let me tell you, this question last appeared in AP May 2023. Now take the next question. This is also of the similar model. So over here also first we will take R plus R3. R is 4R sin A by 2 sin B by 2 sin C by 2. And R3 is 4R cos A by 2 cos B by 2 sin C by 2. Now we can take 4R sin C by 2 common. So we will get sine A by 2, sine B by 2 plus cos A by 2, cos B by 2. Now this bracket is in the form sin A sin B plus cos A cos B, or you can say cos A cos B plus sin A sin B, and the formula is cos A minus B. So 4r sin C by 2 cos A minus B by 2. This is the value for r plus r3. Now let us take r1 minus r2. So r1 is 4r sin A by 2 cos B by 2 cos C by 2 minus R2 is 4R cos A by 2 sin B by 2 cos C by 2. And if you take 4R cos C by 2 common, we will get sin A by 2 cos B by 2 minus cos A by 2 sin B by 2. Now the bracket is in the form sin A cos B minus cos A sin B. What is the formula for sin A cos B minus cos A sin B? It is sin A minus B. So we can write this as sin A minus B by 2. Now after finding R plus R3 and R1 minus R2, we will add them to get the LHS. So let us take what is LHS. LHS is R plus R3 plus R1 minus R2. So that is 4R sin C by 2 cos A minus B by 2 plus what is R1 minus R2? 4R cos C by 2 sin A minus B by 2. So if we take 4R common, we will get sin C by 2 cos A minus B by 2 plus cos C by 2 sin A minus B by 2. So this is in the form sin A cos B plus cos A sin B. The formula is sin A plus B. So we can write this as sin C by 2 plus A by 2 minus B by 2. So this we can write it as sin C plus A minus B by 2. Now from triangle, we can, some angle property, we can write C plus A as 180 minus B, and minus B already we have. So that is equal to 4R sin 180 minus 2B by 2. Now you divide the whole bracket by 2, you will get 90 minus B. We know that sin 90 minus theta is cos theta. That is 4R cos B, which is equal to RHS. Take the next question. This is also important. Prove that 4 into R1 R2 plus R2 R3 plus R3 R1. So 4 into, now R1 we can write it as delta by S minus A. R2 we can write it as delta by S minus B plus R2 we can write it as delta by S minus B and R3 as delta by S minus C. Same way R3 as delta by S minus C and R1 as delta by S minus A. So that is 4 into, so in each term you can see you have delta square. So if we take that delta square outside, so we get delta square into 1 by S minus A into S minus B plus 1 by S minus B into S minus C plus 1 by S minus A into S minus C. Let us take LCM now. So if you take LCM, LCM will be S minus A into S minus B into S minus C. Now if you look at the denominator of the first term, you have S minus A, S minus B, but you don't have S minus C. So let us multiply its numerator with S minus C. So we get S minus C. The same way in the second term, so we get s minus a. And the same way in the third term, so we get s minus b. So that is equal to 4 delta square into 3s. If I take minus common, we get a plus b plus c by s minus a into s minus b into s minus c. Now in the denominator, if we have s into s minus a into s minus b into s minus c, then we can write it as delta. So one s is missing over here. So we are multiplying and dividing by s. Now you see how can we further simplify this. So that is 4 delta square s into, now numerator how can we write, 3s minus a plus b plus c can be written as 2s by the denominator is delta square. Now delta square cancel. So that is 4s into s. So that is 4s square. So 4s square can be written as 2s whole square. So 2s can be written as a plus b plus c by 2s can be written as a plus b plus c whole square, that is RHS. Now take the next question. This question is also important. Show that 1 by r square plus 1 by r1 square plus 1 by r2 square plus 1 by r3 square equals a square plus b square plus c square by delta square. So we will take LHS. 1 by r square plus 1 by r1 square plus 1 by r2 square plus 1 by r3 square. Now we know that r is delta by s. So r square will be delta square by s square plus 1 by delta square by s minus a whole square. The same way r2 is delta by s minus b. So r2 square will be delta square by s minus b whole square. And r3 square is delta square by s minus c whole square. Now you take the denominator to the numerator, it will become reciprocal. So it will become s square by delta square plus s minus a whole square by delta square plus s minus b whole square by delta square plus s minus c whole square by delta square. Now we will expand the numerators, a minus b whole square. So that will be s square plus a square minus 2as plus s square plus b square minus 2bs plus s square plus c square minus 2cs whole divided by delta square. Now s square plus s square plus s square plus s square is 4s square. From these three terms, if I take minus 2s common, we will get a plus b plus c plus a square plus b square plus c square by delta square. So that is 4s square minus 2s into a plus b plus c is 2s plus a square plus b square plus c square by delta square. Now that is 4s square minus 4s square plus a square plus b square plus c square by delta square. 4s square minus 4s square cancel. A square plus b square plus c square by delta square. This is RHS. Hence proved.